Alright guys, welcome back. Video number 4. Here's what I want you guys to do. We're going to start doing some gas calculations. I'm only going to do 16 and 17 because I'm kind of tired and it's pretty late and I still have to do other videos on density. So, here we go. I give you guys this sweet ideal gas formula. Check it out. It has P1 V1 divided by T1 is equal to P2 V2 over T2. Now, if this formula does not make sense to you, what I want you to do is reference the other formula like Charles' law, Boyle's law, Avogadro's law, Gay-Lussac's law, because they will make more sense to you. Now, I'm going to show you how to use this single equation for the following problems. You guys ready? Because I am. Okay, on hot days, you have noticed that potato chips seem to inflate even though they have not been opened. If you have a 250 milliliter bag, which is volume, at a temperature of 19 degrees Celsius, hey, that's T, and I leave it in my car, which has a temperature of 60 degrees Celsius, hey, that's also temperature, what will the new volume be? So we're trying to figure out V2. Now, let's use this formula just for funsies, right? So we have P1 times V1 is divided by T1 is equal to P2 V2 over T2. Now, we have volume, we have temperature, but we don't have pressure. Man, what a bummer. We can't use this formula, right? Wrong. So what I want you guys to do is, since we don't have pressure, let's just forget about it. And now our formula is V1 divided by T1 is equal to V2 divided by T2. So we have V1, which is 250. We have T1, which is 19, is equal to the temperature 2, which is 60. And we're trying to figure out the volume, which we don't know. So let's call that X. Now let's solve for X. So let's cross multiply here, here. Now we have 19X is equal to 250 times 60. And then you solve for X. Moving on. Now, as air is primarily composed of two gases, oxygen and nitrogen, if the total pressure of air is 760 millimeters of Hg at sea level and oxygen has a partial pressure of 160 millimeters of mercury, then what is the pressure of nitrogen gas? In ATM, we'll figure out ATM in a little bit. So what this question is saying, you have a total pressure of 760 millimeters of mercury. We know that oxygen takes up 160. So you have 600 millimeters of mercury left. And that is equal to the amount of nitrogen. Bam. And so that's how you figure that out, right? We know that the total pressure is 760. Oxygen takes up 160 of that. So the remaining pressure is 600, which must belong to nitrogen. And now, this is in millimeters of mercury. So now you guys convert to ATMs. Your conversion chart is up here, right? 760 millimeters of mercury is equal to 1 ATM. If you guys have questions about that, please, please, please come to my advisory. Or I will also be after school on Monday. I believe we should be back by 3 o'clock from our field study. Question number 18. A sample of sulfur dioxide, SO2, is initially at a temperature, and a volume of 20 liters, okay, volume, and has a pressure of 850. Okay, cool. We've got the trifecta here. If the volume changes to 25, so that's volume, and that's probably going to be V2, right? Temperature increases to 181, so that's temperature 2. What is the new pressure? So what is P2, right? That's what we're trying to solve. Now, you just plug into your equation P1 V1 is equal to T1, or divided by T1, sorry, I'm rushing, is equal to P2 times V2 over T2. Now, plug in these numbers, solve for X, and you have your answer. Same thing for this one, and then of course, it's going to be same thing for this one as well. See you guys on the next video, which has to deal with density. Bam. Hey, Crystal, can you just pass me the